Coming up on Factory Made, a burrito recipe that calls for 5 tons of ingredients. You'll need some beans, tortillas, and a forklift. And how many light bulbs does it take to make a television? About 4 million, if it's the world's largest HD TV. Then, nails, paint, and fire make these kicks as tough as leather. But only lemon trees can give these cowboy boots soul. They're not quite homemade, but frozen meals from Amy's Kitchen are made from scratch. And so is their assembly line. Every time Amy starts a run of some of their 150 frozen meals, from pizzas to pot pies, this factory in Santa Rosa, California, restructures its production lines to match the meal. On the menu today, burritos. Lots of burritos. The workers here will pump out 60,000 of them in an 8-hour shift. Talk about fast food. Time to get cooking, starting with the beans. "1,200 pounds of beans pour onto a conveyor to be cleaned. A shaker table separates out any twigs or stones. The beans then soak in running water to speed up their cook time. Next, a giant strainer brimming with those softened beans heads into a large pressure cooker filled with water. This device turns on the heat and fast. Because the lid is sealed, the water reaches a temperature higher than boiling, nearly 250 degrees. The beans cook in 40 minutes instead of 2.5 hours. After this short steam, the beans get a quick dunk in cold water to stop the cooking. This keeps the beans from getting all mushy. At the same time, huge batches of rice are also cooking, but not all the way. If the rice is pulled off the heat just before it's done, the burrito will cook perfectly when it hits the microwave at home. Then over at the cheese station, shredders attack 325 pounds of cheddar and Monterey Jack. That's 500,000 calories. What's a burrito without sauce? Amy's recipe calls for buckets of oil, bell peppers, onions, spices, and tomato sauce. When the sauce is done, it dumps into a large mixer. This is the base of the 8,400 pounds of burrito filling. Here's a handy kitchen tool, a forklift, to carry 1,000 pounds of rice to the mixer to add to the sauce. Next comes a shower of shredded cheese. And finally, 1,200 pounds of those cooked beans. The filling is ready for the production line. But first, workers have to make the tortillas, again on a grand scale. In a giant mixer, they add flour, salt, and oil to make over 500 pounds of dough. This dough baller spits out hundreds of dough balls, each the perfect size for one tortilla. Then, a dash more flour to take out the stickiness so the ball can smoothly slide through this machine. It's called a sheeter, and it stretches the dough twice. But workers give it a third stretch for that home cook touch. The tortillas ride through an oven for less than a minute. Finally, it's time to push out the burritos. Each tortilla gets a squirt of filling. Okay, but it tastes a lot better than it looks. Machines can do a lot of things, but folding the perfect burrito isn't one of them. So these workers do the job, folding 10 burritos every minute for 4 hours. Together, they make enough burritos in a day to feed a Super Bowl stadium filled with hungry fans. After hours in the factory, these burritos are itching to leave. But first, one last pass through a flash freezer. Freezing them takes 45 minutes at minus 45 degrees. Finally, they're ready to be wrapped, packed, and shipped.
When I first started here about 6.5 years ago, burritos were being packaged by hand. Over time, we've come to the realization that there are some processes that would be either safer or more efficient done with a machine. Having to pick up a burrito and put it in, pick it up, put it in. Now you're talking about doing this for thousands of burritos, 8 hours a day. It became more efficient and a lot safer for us to use a machine, and we could still run and still make the same type of a product and package it, but it's more efficient, it's a little safer for everybody.
Today, it was burritos. Tomorrow, depending on demand, it could be pizzas, pot pies, or veggie burgers. Whatever the meal, Amy's production line is ready to transform itself again to feed a hungry microwave near you. Times Square is famous for them. Every big sports stadium in America has one. Giant video displays. With these huge screens, fans won't miss the close-up or that modern sports institution, the instant replay. Every year, big TVs get bigger. But the world's newest, largest high-def LED display dwarfs all the rest. It weighs over 35 tons, is 85 feet wide, and 105 feet tall, about as high as a 10-story building. The challenge is how to design a screen that big and produce a clear, colorful picture. And then, get a really big house so you can have one at home. Well, maybe not. Here, at Daktronics in Brookings, South Dakota, they're building every sports fan's dream. And no, you can't buy it. It's already on order for the Kansas City Royals baseball stadium. But this giant has some things in common with a dinky home set. The images are actually made up of tiny points of colored light, called pixels. It's amazing that something this big starts with millions of things so small. Most screens use only 3 colors, blue, green, and red LEDs, to generate these pixels. Together, the trio creates every known tint that the human eye can see, as many as 10 million colors. LEDs, or light-emitting diodes, are little light bulbs that emit a single color with high-intensity light. So intense, you can see them clearly, even in bright sunlight. The diodes need a place to call home, so at the heart of every giant video display is something called a module, the basic building block of the screen. It's a circuit board encased in a plastic shell. It takes up to 126 modules to make up a section, and 66 sections to make up the world's largest high-def LED screen. That's more than 7,000 modules. The module circuit board manages all the electronic components in the screen, sort of like a board in the back of your computer. It all starts with these tiny connectors. They control the flow of electricity to the LEDs. Without them, the screen would go black. This machine knows just where to put the connectors, and it's fast. It can pick up and place 37,000 components in an hour. That's more than 600 each minute. And it's called, what else? The Pick and Place. 2 revolving heads tag team the boards to reach maximum speed. One picks, the other places. Here's another fast worker. It's called the radial insertion machine. Not as catchy a name as Pick and Place, but it works just as hard and fires LEDs like a machine gun. 300 of them a minute. It places more than 4 million LEDs on over 7,000 circuit boards for this display alone. That's a ton of lights. Now the board gets a special bath designed just for electronics. It's dunked in molten solder. Solder is a tin-based metal alloy. It only sticks to the metal components where it needs to complete connections. The boards get their own foul weather gear too. Any moisture leaking in could cause a short circuit and loss of picture. Bad news for the fans. When this rubber-like sealant hardens, it's tough enough to repel rain, sleet, or snow. Add one sunscreen to reduce glare. And these circuit boards are done. But will they play together nicely when it's game time in Kansas City? Thousands of circuit boards, millions of light-emitting diodes. But how do you get from this to this? Counting down to the big TV's premiere requires a few more steps. Starting with the frame, which is aluminum, durable, and relatively light. First, the punch press cuts all the holes needed for wiring and screens. It doesn't even need an operator. If there's a problem, the system itself will phone for help. Then, the press brake bends the metal sheets into the cabinet walls and sides. Looks simple, but it's a high-precision job. And the stakes? Well, if the parts are off by just the thickness of a baseball ticket, they won't line up flush. Errors show up as dead space in the picture. And that would be bad, especially during a big play. Front and rear pieces join the picture next. The cabinets are then stacked and bolted into units of 4. Each will support more than 1,500 pounds, the average weight of one of the TV's 66 sections. To make everything light up, you need electricity. That means lots and lots of cable. Mounting the power supply, wiring the individual sections, and securing all the modules in the display. And finally, testing. Before a technician powers up the display units, he checks for shorts or loose wires. Then the image data, or map, shoots through a fiber optic cable to the display. In a flash, each of the millions of tiny LEDs gets its own lighting command. Now the screens run at full intensity for 12 hours. Long enough for any problems to appear. The displays are ready to roll. From South Dakota to Kansas City, where Royals fans will get to watch the largest high-def television in the world. In-home delivery here takes on a new meaning. A 100-ton crane hoists the sections into place. 66 in all, one after another. This giant is massive and stands taller than the length of a basketball court. After thousands of man-hours and a battery of field tests, Kansas City's new Colossus is ready for opening day. The team's hoping the mega screen for scores, stats, and instant replays with plenty of room for ads will be a grand slam. Most cowboy boots these days will never meet the side of a horse, but their distinctive shape was originally designed for life in the saddle. They were made for stirrups. With pointy toe and treadless sole, they slipped in easy. But with a stacked heel, they stayed on tough and kept a cowboy's foot snug in the stirrup to better keep his seat in the saddle. Today, the cattle drive era may be riding off into the sunset, but the cowboy boot is more popular than ever. The Lucchese Boot Factory in El Paso, Texas, kicks out as many as 900 boots a day. It takes 250 workers to keep the cowboy boot looking cool and hot with a little extra flair. These bestsellers are sure to make customers want to die with their boots on. The basic 15-day process starts here in the leather room. 75 different kinds of animal skin line the walls. Everything from alligator to rattlesnake to the downright exotic.
This is a stingray. As you can see, there's the stinger. And this skin is like armor. It will never wear out. Oh.
Step 1 is to cut the skin. This ostrich hide will make 2 pairs of boots. A worker looks for the best natural patterns on each skin before he makes a single cut. These metal tools are called dies. They're like cookie cutters, one for each part of the boot. 4/4 of the shaft, the top of the foot, and the heel for every size. This hydraulic press punches out a pair of heels. The next step is to decorate the shafts. Lucchese knows how to dress up a boot and wrangle a nice price for it. These intricate designs are handcrafted and could cost you thousands of dollars. But the basic boot gets its flourish from an automated sewing machine that speeds along at 1,200 stitches per minute. More complicated designs are handcrafted, like raised cording. First, a worker brushes glue on the skin. Then he lays a stencil on top and presses cord into the stencil to create the pattern. He sews a soft lining over the cords, then stitches it into place. The hidden cord is now a raised pattern. Style's one thing, comfort's another. So to keep a cowboy comfy, a worker sews the boot inside out, trims the hard edges, and flattens out the rough seams so they won't rub against the leg. Then, the boot is pulled right side out and gets another rub down. Now, the foot. The distinctive pointy toe was born out of function, but today, it's gone to fashion. So shaping is a key part of the process. A worker soaks the boot leather in filtered water so it's more pliable. And with a mouthful of nails, he pulls the leather around a mold called a last and hammers it to the inner sole. Now that this finally looks like a boot, it goes into a room called the hot house to dry for a day. At 100 degrees, the hot house is not really that hot, but it's enough to cure the boots. The heat literally bakes the memory out of the leather, so it forgets the shape it had on the animal's back, takes on a new identity as a boot. Once the shape is completely set, workers give the boot its sole. First, a steel shank for strength and stability. Next, an inner layer of hard leather. Then, a softer leather cushion for the ball of the foot. And finally, the outer sole. But what holds it all together? 60 pegs made of lemon wood.
These pegs will stay in place because as you wear the boot, the moisture and the heat from your foot will keep those pegs swelled up and they'll never move again.
Lemon wood also keeps a soft, spongy feel that makes it easy on the foot. The heel gets a shot of glue and a ring of nails. Next, a sanding to make sure it's level and lays flat on the ground. Then a rubber bottom, and finally some paint to the sole. But it's still not done yet. These boots need to look sharp before they can hit the streets. So workers stamp, scrub, and buff the boots. Then, a spin on the warming tube smooths out any wrinkles. Now they're pretty and tough. So tough, they're baptized with fire. But just to burn off excess thread. Finally, after 15 days and multiple quality control inspections, these boots are made for walking. A sure fit for the urban cowboys or the real McCoy.
接下来，超级强权大比拼，北美重型机器挑战欧洲钢铁怪兽，超猛机器王，欧美大赛就在 Discovery 热门9点档接着播出。